The topic for lesson 1-2 is linear measure and precision. You'll learn to measure segments and determine accuracy of measurement, and to compute with measures. Why are units of measure important? When you look at the sign, you probably assume the unit of measure is in miles. However, if you were in France, it would be 17 kilometers, which is a shorter distance than 17 miles. Units of measure give us points of reference when evaluating the size of objects. Unlike a line segment, or just segment, can be measured because it has two endpoints. A segment with endpoints A and B can be named as segment AB or segment BA. The order doesn't matter. The length or measure of segment AB is written as AB without a bar over it. The length of a segment is only as precise as the smallest unit on the measuring device. On a ruler, the smallest unit is frequently labeled as centimeters, millimeters, or 1/16 of an inch. The 0 point on a ruler may not be clearly marked. For some rulers, 0 is on the left edge of the ruler. On others, it may be a line further in on the scale. If it is not clear where 0 is, align the endpoint on 1 and subtract 1 for the measurement at the other endpoint. Now, it's interesting with the metric rulers we have, because it's commonly labeled millimeters, for each of these little marks, but the big numbers are actually centimeters. So to find the length of segment LM, we could say LM equals either, it looks like 42 millimeters, or that would be the same as 4.2 centimeters. It didn't say which unit to use, so we can look at both. This one's straightforward. Find the length of QR. So QR, I'm not putting a bar over it because I'm talking about length, is going to be 5 centimeters. It's already lined up for us. Now, in customary units, we get to work with fractions. So that first half is marked as a half, then half of a half is a fourth. So 1/2 plus 1/4, that would be 3/4. And then I'm running out of room. Okay, half of a fourth would be an eighth, and so on. So for this one, it's just going to be straight out 3 inches. And sometimes I like to write that like they do in construction. Those have the same meaning, 3 inches. Okay, this looks like it's measuring to the nearest 1/4 of an inch, so that would be 3/4. So it's going to be 2 and 3/4 inches, or we could write 2 and 3/4 inches. More common in math to use the IN. The precision of any measurement depends on the smallest unit available on the measuring tool. The measurement should be precise to within 0.5 or 1/2 unit of measure. So if we have 3 centimeters, the actual length could be no less than 2.5 centimeters, but no more than 3.5 centimeters. Okay, to find the precision for 32 and 3/4 inches, I made a little sketch of a little fake ruler to help us see that this is being measured to the nearest 1/4 of an inch. And then they want us to explain the meaning. Okay, so using our definition of precision there, half, I'm going to use the fraction half since that's a half. Half of a 1/4 is 1/8. Okay, so that is the precision. So then to explain the meaning, we're going to look for that range of values that the actual measurement could live in. I went ahead and changed 3/4 to 6/8. We had a common denominator. So 32 and 6/8 minus 1/8 would be 32 and 5/8. 32 and 6/8 plus 1/8 is going to be 32 and 7/8. So summing it up, the precision is 1/8 of an inch, and the measurement could be from 32 and 5/8 to 32 and 7/8. So that's our explain the meaning of. Okay, now I'm going to try to make you a fan of the metric system. They ask us to find the precision for 15 millimeters. Well, it's half of the nearest unit it's measured to, so half of a millimeter, we're going to write that as 0.5. Okay, that's just what it is. 1 times 0.5 is 0.5. Explain its meaning, so now we're going to do our addition subtraction bit. So if we subtract 15 minus half a millimeter, or 0.5 millimeters, it's going to be 14.5 millimeters. And if we add, obviously, 15.5 millimeters, I'll let you have the nice typed version here. So the short answer is the precision is 0.5 millimeters, and the measurement, so our explain, could be from 14.5 millimeters to 15.5 millimeters. Recall that for any two real numbers a and b, there is a real number n between a and b such that n is between a and b. This relationship also applies to points on a line and is called betweenness of points. Point M is between points P and Q if and only if P, Q, and M are collinear and PM plus MQ equals the length of PQ. So if I make up some fake numbers and say the length of PM is 2 and the length of MQ is 3, then the length of PQ should be 5. Because measures are real numbers, you can compare measures. If x, y, and z are collinear in that order, then one of these statements is true. Either the length of xy is equal to the length of yz, or the length of xy is greater than the length of yz, or the length of xy is less than the length of yz. In this problem, they ask us to find the length of LM, and we can see that LM plus MN equals LN, because M is between L and N. So we don't know the length of LM, but we know MN is 2.6 and LN is 4. So we're going to subtract 2.6 from both sides of the equation. Add a little bit of borrowing there, a little arithmetic, never hurt anybody. So we get 1.4 and our units were centimeters. Find xz, and we can see that y is between x and z, so xy plus yz should equal xz. So all we need to do is add 4 5/8 plus 2 and I'm going to go ahead and write the 1/2 as 4/8. Common denominator is nice for adding fractions. So we have 6 and, 9/8. That's a little improper. We can fix that. So that'd be equivalent to 7 1/8, and our units were inches. Find x and the length of ST if t is between s and u. Okay, and then part of this is already labeled on there. ST is 7x. SU, they did not label, is 45. And TU is 5x minus 3. Okay, t is between, so we can do UT plus TS equals SU or US, doesn't matter. So substituting in what we know, 5x minus 3 is UT, plus 7x equals SU is 45. Now to find x, we have just a little bit of algebra here. We'll combine like terms. So 5x plus 7x is 12x, minus 3 equals 45. And then add 3 to both sides of the equation. So 12x equals 48. And if we divide by 12, we get x equals 4. Okay, so that was the first thing we had to find was x, and they also want us to find st. That's the easy part now, because we know x. So all we have to do is substitute into the st expression. 7 times 4 is 28. Two segments having the same measure are congruent. The symbol equals with a tilde on top of it is read congruent to. The red slashes on the figure also indicate that the segments are congruent. The graph shows the percent of adults who participated in selected activities. Suppose a segment was drawn along the height of each bar. Which categories would have segments that are congruent? well, the congruent segments would have the same percent, so the same height. So we could have the two things that are both 16% would be congruent to each other, and the two things that are both 14% would be congruent to each other. So museums and picnics, and the zoo and playing board games would be congruent because the bars have the same height. Constructions are methods of creating geometric figures without the benefit of measuring tools. Generally, only a pencil, straight edge, and compass are used in paper and pencil constructions. You can construct a segment that is congruent to a given segment by using a compass and straight edge. We will do some computer-aided constructions, kind of gone away from doing on paper and pencil. The precision of any measurement depends on the smallest unit available on the measuring device, and the measure of a line segment is the sum of the measures of its parts.